Hi, welcome. In this video, we will solve climbing stairs asked by companies like Amazon, Microsoft, and Google. Hey, hello everyone. Welcome to this DP series. Okay, we are going to solve first question on DP series. Okay, here I will give you a complete guide how you can think in recursion, how you can solve problems on recursion on DP. We will talk about 1D DPs. Okay, then we will talk about all the approaches that top down approaches, bottom up approaches, and how to do space optimization. Okay, so let's start with the first problem. So we have this problem: climbing stair. You are climbing at a staircase. It takes n steps to reach the top. Okay, so there will be some n steps that it will take to reach the top. Each time you can either climb by one or climb by two steps, right? So either you can take one step or two step. So in how many distinct ways you can climb to the top? Okay, so whenever they are asking, right, distinct ways, okay, or suppose the question is number of waves, okay, or suppose find the number of paths, okay, so number of paths, all these, if these are all questions, you should first think in recursion, right? Because these are recursion questions, right? Number of waves, number of paths, number of distinct ways. And if in these paths, right, in these ways problem, if they are asking find the maximum path, right? Suppose maximum path, or here the maximum sum path, that is also a recursion question. And if they are finding the best path, or the path will take the minimum number of days, okay, path will take minimum days, path will take maximum days, right? So all these questions are comes under recursion and DP. So what is DP? DP is basically dynamic programming. So see, recursion is all about function calls, right? This function call will call again one function call. Okay, then this function call again call these same functions, right? So by the help of DB, you are storing these values, so you won't do again and again same function calls. Okay, so we will talk about it, but let's try to understand it here. So let's take this question. In this example one, we have n equals to 2. Okay, that means a staircase of 2 steps. Okay, and I am standing at here, right? So how many there, what are the distinct ways to reach to the top of the staircase, right here? So I can take first step here, okay, and then I can take second step, right? So I can take one step, then one step, or I can directly take two step, right? So only these are the two ways possible, right? Two ways possible. Okay, now suppose if n is equals to 3, n equals to 3, and again you are standing here, right? So what are the possible ways that you can reach to the top of the staircase? So basically you can take one step here, then one step, then one step, right? Then one of the case is either you can take a one step jump and then a two step jump, right? Or suppose one case can be that you can take a two step jump first and then do a one step jump, right? So what are the possible different ways? Either you can take one step jump, one step jump, one step jump, or you can take a one step jump and then a two step jump, or you can directly take a two step jump and then a one step jump. So these are the three ways that are possible here. Okay, so now let's see how we can solve this problem. Okay, so let's try, and let me copy this so that we will get a bit of idea. So let me copy this stuff. Okay, let's, it is here, and we have this one, well, here. Okay, so this is about n equals to 2, and this is about n equals to 3. Okay, let's take one more case when n is equals to 4. Okay, let me create here, and I want a similar type of figure, so just give me a second. So now here I have n equals to 4, right? 4 steps here. So what we calculated for n equals to 2, that either you can take one step jump, and then you can take a two step jump. Okay, these are the only possible steps you can take. You can either go for a jump of 1, right, or you can take a jump of 2. That's it, right? Two things that you can do. So that will be the two ways. Okay, one way here in n equals to 3, that is you can take one step jump, one step jump, one step jump, Then you can take one step jump and a two step jump, and then you can take a two step jump and one step. For n equals to 4, either you can take a one step jump, one step jump, one step jump, total 4, or you can take a one step jump, then two step jump, then one, or let's suppose one only, then two step jump. Okay. Then you can take a one step jump, then two step jump, then one. Okay. Or you can take a two step jump, then one step. Okay. Or you can take a two step jump, then again a two step jump. Right. So there are total how many ways? 5 ways. Okay. Here 3 ways. Here 2 ways. Okay. So how we can think that this problem is in recursion? First of all, the only hint is whenever they are these questions are number of ways, number of paths. Okay, you can think in a recursion and see what is basically recursion. So recursion is when you simply break down a problem into the smaller problem of itself. Okay, basically how we write a function, right? We write the function. That function can represent itself, right? That can call itself, right? So suppose we have function of suppose factorial, right? And this function calling itself here, right? So recursion is whenever there is a big problem, right? A big problem, okay? And can you break down the problem, basically break down the problem into the smaller version of itself, smaller version of itself, that's a recursion. Okay, that's basically a recursion. So basically if let me give you one example here. So suppose I want to say that you need to find a square of 5, right? How you will find a square of 5, right? So what will be the square of 5? That will be 25. Okay, but can I write this square of 5 like 1 plus 4, right? And basically what is the formula of a plus b whole square? That is a square, square of 1, then square of 4, then square of not square, that is 2 into 4 into 1, right? Basically this is how you will find a square of 5. Now can you see that you have break down a problem like this? Now a problem part can also be further breakdown, right? So now the same question, if I say how you will find a square of 4, so you can simply say I can find a square of 1, then square of 3, then 2 into 3 into 1, right? Then how you will find a square of 3? Basically you can find a square of 1, then square of 2, and then 2 into 2 into 1, right? So you can see, right? You have one value, right? Now this value is calculated by square of 4, and square of 4 will be calculated by square of 3, and square of 3 will be calculated by square of 2, and it is calling itself, right? It is automatically calling itself, right? Basically square of 4 will be calculated by square of 3. So basically you are representing a bigger problem into the smaller version of itself, right? So you are saying if you want to find a square of 5, you need to find a square of 4. Then you are saying if you want to find a square of 4, you need to find a square of 3. Then you are saying if you want to find a square of 3, you need to find a square of 2, right? And similarly in the end result what you will do, see, suppose let me just give you a bit of idea here, that you will go ahead, you will say square of 2 will be square of 1, and square of 1 and 2 into 1 into 1. Now what you can do, you can simply say that I know what is the square of 1, like we will, this is called base case, right? That you know that square of 1 is 1, right? Although you know the square of 5 also, but see, suppose if there is a very big number 202,225, something like this, right? So you know the square of 1, what you will do now, you will simply place with 1 and here not. So what will the total answer? That will be 2 plus 1 plus 1, so 2, that will be 4, right? So now you are getting a square of 2 value with 4, so you will fill a value with 4, and you will fill a value here, so you will get a square of 3, that will be 4 plus 4, that is 8 plus 1 9, so you will fill with a value of 9, and you will place this value here 9, so you will get 9 plus 1 10, and this 16, right? So it will be 16, you will fill a value here 16, 16 plus 1 17, plus 8, what you will get 25, So you will fill the value of 25 and here the answer will be 25. And this is how recursion called. First of all, right, you break down a problem into smaller problem, smaller problem, smaller problem. You reach to the base case, you fill the base case with the value, and then value itself again simply fill the all upper values and it will reach to the end. This is how basically you can think in a recursion. Okay, now let's come back to our main problem, right? So see, can whatever I have said here, big problem breakdown in the smaller problem, can I think a pattern of like here as well? Let's see here. If you can think closely, right, are you getting any number of ways in n equals to 4 that is resemble to n equals to 3? Yes. If you can see here, if you can see, basically, you can remove the one step, you will get that these are basically ways of n equals to 3, right? Here, if you remove like here, sorry, I guess this should be 2 1 1, not 2 1, 2 1 1. So it will be 2 1 1. So here as well, if you can see here, right, this is your number of waves of 2. So basically here, this is of how you can find waves of 3. This is how you can find waves of 2, right? Basically, what I did, I simply removed the one step, right? I removed the one step and basically that's a wave of 3 and that is true, right? Suppose you want to reach, at the top, right? You want to reach at the top, right? But if you just reach to the one step, suppose you are standing here, now the same problem is converted to waves of 3. If you are reaching one step, right, now the same problem is converted into waves of 3 and that's it. If suppose you are reaching a 2 step, now the same problem is converted into waves of 2, right? Similarly here, you can see a pattern here as well, right? That if n equals to 3, right, and you are doing one step only, the same problem can be converted into waves of 2. And yes, that's it. That's how you are converting into waves of 2, right? If you are doing a 2 step, right, the same converted will be waves of 1. Okay, so yeah, that's how we will call it. Okay, and we will find out the base condition, right, and how we will get to know what is the base. So always think that when you are, right, when you reach to the top, right, you are here, that is also a one way, right? That's a possible way that you are simply standing there itself, right? That is you reach to the step. So let me write it. So basically you have one function, suppose waves, and you need to find out waves of 4, right? And for this waves of 4, you can either run one step or two step. So if you are doing a one step jump, right, now the same problem will become waves of 3. Let me do it here in the new window so that it will be clear. So I have a problem of waves of 4, right? And if I'm doing a one step jump, right, the same problem will be converted to waves of 3. If I'm doing a two step jump, the same problem will be converted into waves of 2, right? 4 minus 2, 2, 4 minus 1, 3, right? Again, how I will find waves of 3? So I will take a one step jump, right? I will take a one step jump. The problem will be converted into waves of 2, right? Then I will take a two step jump. The problem will be converted into waves of 1, right? Then now how I will solve waves of 2? I will simply take a one step jump. Problem will be converted into waves of 1. If I am taking a two step, problem will be converted into waves of 0, right? And for how I will calculate waves of 1, I will take a one step jump, problem will be converted into waves of 0. Why am I stopping at 0? I will tell you why I am stopping at 0, because that's a condition. You reach to the point, right? 0 is the point that you reached it, right? Basically you are standing at here, right? So you reached it, that point, after 4 step, and you can see, right, waves of 4, right? You have done a one step jump, then again one step, then one step, then one step, and you have reached here, right? This is your 4 step jumps. Okay, now let's continue here. So that is a waves of, if I do a one step jump, that will be a waves of 0. Okay, let's see. Like here also, if I'm doing a waves of two, like in each I can do one step or two step. But if I'm taking a two-step jump here, what it will be? It will be become waves of -1, right? And here, if I'm taking a jump, it will become waves of -1, right? So here I will stop. Now again, one step jump, I will be at waves of 1. If I'm taking a two-step jump, I will be at waves of 0, right? Again, one step jump will be waves of 0. Two-step jump will be waves of -1. Okay. So now let's see, when you are reaching to the 0, that's the point where you need to reach. Okay, so can I say that's a one way, right? That's a one way, right? So what I will do for this function, I will return with 1. I will return with 1, right? Okay, and here waves, I am reaching to -1. So basically, suppose there was one step, right? You need to reach at one step, right? But you are taking a two step. You are reaching a two step. That means you are not able to reach by two step. Okay, so can I say this waves of -1 basically return 0? So what I will do, this will return 0, and what I will return to waves of 1, basically I will return the summation of it. So 1 plus 0 will be 1. So I will return 1 to it, right? So you can understand it like this. From here, you are returning 1. From here, you are returning 0. And the total value will be 1 plus 0. That will be 1. Now, waves of 0, we have already calculated. Okay. What will the value 1? So, from here, you will return 1. Right. And from here, what you will do? You will return 1. So, the total value will be 2. Right. Here, you will return the same 1. So, 1 plus 1, it will become 2. Right. Now, let's check out here. Here you are getting 0, so it will return 1, right? Here you are getting -1, it will return 0. 1 plus 0, it will become 1. Okay. Now here you will return the same 1. Here you will return 2, right? So waves of 3 will become 2 plus 1, that is 3. Okay. Here you are getting waves of 0, so you will return 1. Here you are getting -1, so you will return 0. 1 plus 0, it will be 1. Here you will return 1. So here you are returning 1. Here you are returning 1. So 1 plus 1 will be 2, right? And here you are returning 2. Here you are returning 3. 3 plus 2, that will be 5, and 5 will be our answer. Okay. Now let's understand here. I got here waves of 1, right? Or here I got waves of 2. Let me use a different pen. Here I got a waves of 2, right? But still I have calculated here waves of 2. Why? Why again I called it? I know that the value is 2. Here also I got the 2. Why I again call it? Okay, here I get the value of waves of 1, right? But I have called here as well waves of 1. I called here as well waves of 1. Why? I got the value here waves of 0. So that's it. Okay, the last condition was waves of 0 only. But right, when I am getting 2, why I'm calling it again? So that's here where the DP comes into play, right? So what it will do, basically it will store your function values. It will store your function values. So see, suppose you calculated waves of 2 here, right? In some time, it will store the value 2 in some, suppose, an array, right? So basically it will store that two way, like finding out two ways. There is a, like, there are two possible ways to find a step of 2. So if this function is called, you don't need to call again waves of 1, waves of 0, and all these things. You will remove, you will eliminate all these things. You will eliminate all these things, and you will directly return 2. This is what DP is, right? It is reduce the function calls, right? Here you are not calling again the same function again, right? Waves of 2 is called here. Why I'm calling it again, right? When I will call it, I will simply return 2. That is how DP comes into play. Okay. So now let's see how we can simply solve this problem. Right now we are getting that basically for a waves of 4, okay, waves of 4 is nothing. Basically it's finding of waves of 3, then waves of 2. Okay, what is waves of 2? Basically it is nothing. Waves of 3, it is finding a waves of 2, then waves of 1. Okay, similarly, if there are n ways, right, if there are n ways, what are the possible ways to find it? Basically, waves of n minus 1, that means taking one step, and waves of n minus 2, that is taking two step, right? And yes, that's done, right? Now these will be calculated by their own function calls. You don't need to worry about it. Okay, these will calculate. You just need to take a one step. Here you have taken a one step, the waves of 3. If you are taking a two step, then it will be waves of 2, and then it will call itself. So for finding a waves of n, we just need to find waves of n minus 1 and waves of n minus 2, and the summation will be my answer. Okay, so how I can write this in code? So basically what I will do, I will simply write a function. Suppose waves, this is my function, right? And where I have a value of n, and I will simply return what, that my, if you want to find the waves of n, you need to find first waves of n minus 1 plus waves of n minus 2, right? And that's will be answer. But we need to stop it here, otherwise it will call it again and again, again and again, it will reach to the infinity. We need to stop it here. When I am stopping, whenever I am finding waves of 0, and when I am finding waves of some negative value, right? So whenever there is a waves of 0, that means whenever your n is equals to 0, can I say that, can I say whenever my n is equals to 0, I will simply return 1. That means there is a one way. And whenever, if my n is less than 0, I will simply return 0, and that's it. Basically this is how you can solve this problem, right? But where is dp? We have not used dp. It will again call the functions, right? It will call functions. So suppose, basically it will call waves of 4, then waves of 3, waves of 2, and so on. But I want to store the values. I want to store the values. So what I will do, I will simply store values in one. I will take one array, right? Suppose I will take one array dp, this is like an array, right? And what I will do, instead what you can do, suppose if there are n ways, so you can create your dp size of n, right? Suppose if n is equals to 4, so I will create a dp size of n equals to 4, and I will simply define with -1. Okay, what I will do, so let me define like my dp of array of size with -1, -1, -1, -1 here. Okay, and what I will do, I will store these values here. That means I am finding a dp waves of n, so I will store a dp of n, right, the value, and I will return the value. I will return the value. Okay, and here, if, what I will do, see, I don't want this function call to be happen. So what I'm saying, whenever you are calling this dp of n, and if it is already defined, if dp of n is defined, that means if it is not equals to -1, because first initial it is filled with -1. If dp of n is already defined, that is not filled with -1, simply return dp of n. So basically this is how you can solve this problem. This is all about how we are using dp. Okay, so let's see basically how I will store all these values. So let's take one function of waves of 3, right? So, or I will give you a hint in the dry run video. Okay, so let's wait for this dry run video. The next video will be the code implementation. I will give you a complete code of this. Okay, how to implement. Basically it will be exactly like pseudo code. Okay, but yeah, I will give you the code implementation of it, and after the code implementation we will talk about how these function calling will happen, and how we will use dp to reduce our function calls. Okay, so yeah, that's all about this video. See you in the next video.